So we are finishing up this problem. So we had, I think there was 3 yellows, one purple, and 2 blues. So what's the probability of randomly choosing a yellow glove first? Okay, how many gloves are there? 3 out of how many? 6. Now, here's what we need to talk a lot more about, is this probability of B. Here's what happened, why they got the answer that they did in our math. If you remember, our math wasn't matching up with how many they were counting. Here's the reason why. The probability of B happening, okay? There are 2 scenarios that this can happen. I can take and I can pull a blue first and then a blue. Can that scenario happen? Yes. Because how many blues are there? 2. But I can also pull a what? I already have a blue and then a blue. That's going to account for the other thing. I don't want to get specific with yellow, because that's not the only one I could pull. I could also pull purple. So how do I say you can pull something? I can pull blue and then I can pull blue. Or I can pull a...
Pull blue.
I can pull a not blue, which takes care of yellow and purple. Be with me on that. Instead of having to do every scenario, if I just do its complement, then I'm going to get everything else. And then what do I still need to pull though second? What are the chances of me pulling a blue? 2 out of 6. What are we then the chances of me pulling another blue? 1 out of 5, which then when I multiply that gets me 2 out of 30. Does that make sense? I could pull the first blue 1, and then I could pull blue 2. Or I could pull blue 2 first, and then I could pull blue 1 second. Does that make sense? So there's 2 scenarios where I could pull blue and blue out of the total of 30. With me on that?
Yeah.
And if you went up to our chart, if you go up to our chart, you're going to see 2 blue blues. 1 here and 1 there. You with me? Yes or no? Need some kind of something. Okay. A next scenario. Man, I went really far. Really far. The next scenario is not blue. How many chances do I have for not blue? 4 out of 6. How many chances do I have for blue being picked next then? 2 out of, and when I multiply that, I get 8 out of 30. I add those 2 together, get my 10 out of 30, which reduces to my 1/3. That's where we got that answer of 1/3 from. Does that make sense? Now, the next one says the probability A and B. This is definitely a tricky problem, because what does it mean? Remember how we had probability of A? We've already figured that out. We're going to add the probability of B, and normally we just took those 2 and multiplied them together, and then that was our probability of A and B. This is not the case for this one. Okay, this is not the case for this one, because this guy right here, this probability of B is including a B and a B in it. When I do my AND, there's no way for me to have B and B together because I had to have a yellow first. So I have to actually recalculate this one out. I have to recalculate it. So here's what I mean. When I go to find the probability of A and B, I do the probability of A, but then I multiply it by the probability of B given A. That's the difference. Do you understand what happened there? Matt, you with me?
Given A.
I have to, in order for this to happen, in order for A and B to happen together, I have to have a yellow and a blue.
Okay.
It's got to be and. There's only, you got to have the yellow pulled first and the blue. The chances of that happening mean that I pulled a yellow for my first one. So when I go to find the probability of B, I have to assume that a yellow has been pulled, and I need to find the chances of pulling a blue second.
Hi, you're teaching me solve the problem. Oh, ironic. Can I just count these?
Yeah. All right. So what's the probability of A happening still? What are the chances of pulling a yellow first?
1/2.
3 out of 6, 1/2. Times, what's the probability of B given A has already happened? How many blue gloves are there?
2.
2. Out of how many now? 5. Do you see how that has changed from when we were up here? What was my probability of B up here? 1/3. What's my probability of B given A down here? Do you see the difference between the two? Okay, so you have to think about that. The reason that this happened is because the probability of B had 2 different ones that we had to add together. We had probability of B and B happening and probability of not B and B happening. This one, we've got to recalculate it because we have to have A had to happen first before I can calculate the probability of B happening. Does that make sense? Okay, so you multiply that out, and you get 2/10, which reduces down to 1/5, which is what they got. Good? Now how do we find our OR? Put all that together. They're going to sit there and they're going to take, what was our probability of A?
1/2.
What was our probability of B?
2/5.
Nope. That was the probability of B given A. Remember we just said those two things are totally different. What was the probability of B happening?
1/3.
Minus, what was the probability of A and B happening? Does that make sense? Now, I'm going to make them all have common denominators, which the common denominator is going to be 30. This becomes 15, this becomes 10, and that becomes 6. And then I get 19. Go ahead, and I'm going to give you a minute to try this one, because it's very similar to it. Go ahead and try this one. 7 on page 74. Here's what you should have done. First, in order for me to figure out, this is the probability of yellow or yellow, correct? I have to find the probability of pulling a yellow first, correct? I have to find the probability, so that's A. And then I have to find the probability of pulling a yellow second, and I have to minus the probability of pulling yellow and a yellow. I don't know what's going on up here. You with me? Now, this one's very straightforward. What are the chances of pulling a yellow first?
1/2.
Now, this one is not so much. That's why it's very similar to the one before. I have 2 different things where I can pull a yellow second. What are the ways that I can pull a yellow second? I can pull a yellow and a yellow, or I can pull a not yellow and a yellow. Now, what we did last time. You understand what I'm talking about? Okay? What happens with this? What's the probability of pulling a yellow and a yellow? We have 1/2 times
3/5.
2/5. If you pull a yellow the first time, you can't pull another one. This is out without replacement.
Oh.
So then that becomes 2/10. Yes?
Yeah.
Plus, what's the chance of not pulling a yellow? What is it? No. 3/6 or a half times, what's the chance of pulling a yellow on this one now? 3/5. With me? Which then this becomes 9/30. Yes? Times by 3 times by 3, you get 6/30. When you add that together, it becomes 15/30 or a half. The whole answer is 1/4. This is just this part. So you have a half plus a 1/2. Now what else do I have to find? The probability of y, and then I have to find the probability of pulling a y second, given that I pulled a y the first time. Remember I was talking this through. Okay, so let's do that over here. What's the probability of pulling a y? And I'm going to multiply it by the probability of getting a y the second time given a y the first, correct? So what's the probability of this? 1/2 times what's the probability of pulling a yellow the second after I know I've already pulled a yellow for the first one? 2/5, which then makes this become 2/10. Correct? So, a minus 2/10. Okay, what happens here? What is a half and a half added together?
1/4.
You have a half of a cookie, you add another half of a cookie. How much do you have? A whole cookie.
Oh, yeah.
You do not add tops
Oh,
and
right,
tops
I
and
pulled
bottoms and bottoms.
Oh,
Yes. A lot of stuff went on there. Okay? You add these two. What does that give me? 1. This becomes 1. So that becomes 10 out of 10. Then I can do 10 out of 10 minus 2 out of 10, which becomes 8 out of 10, which reduces down to that 4/5, which we were looking for. I don't know if it's right. That's the way we should do it. Does that make sense? Yes. Which one? This one? Or this one? This one. You have to, so to get yellow second, because there's more than one yellow, I can pull a yellow first and a yellow second. So I have to calculate those chances and add the chances of not pulling a yellow with a yellow to it also. Because there's two different scenarios that my yellow can come up second. A yellow and a yellow, and a not yellow and a yellow. Because all this one concerned is, it just wants a yellow to come up second. Doesn't matter what the first one is. So how do I combat that? By making a yellow and a yellow, and then a not yellow and a yellow. That takes care of, look, this is a half and this is a half. That takes care of all the different scenarios that could happen up front. Does that make sense? Alright? Moving on. So I'm going to pause the video. We're going to go to activity. So here we go. Activity 6. Whoops. Alright. So you often see the phrases with replacement, without replacement in probability problems. These phrases refer to whether or not the total sample space changes from the first to last event. For example, if you draw a marble from a bag, record the color, and then replace it, the sample space for the event remains the same. We've talked about this. If you do not replace it, then the sample space decreases. A standard deck of playing cards contains 52 cards. This is something that maybe not all of you know. You're going to need to know these facts in order to find probability for our next problem. So there's 52 total cards. There's 4 suits. There are spades, clubs, hearts, and diamonds. Each suit has 13 cards. There's an ace. There's the numbers 2 through 10. There's 3 face cards, which are jacks, queens, and kings. So, using a standard deck of playing cards, calculate the following probabilities for randomly drawing 2 cards at one at a time with replacement. So everybody understand what our task is. So what's the chance of pulling a ace first? How many aces are there in the deck? How many aces are there total? 4. How many cards are there total? 52. 4 out of 52. Which reduces to 1/13. Yep. Especially since, so think about this. If I'm multiplying fractions, do I need them to have common denominators?
No.
So I can reduce right away, that way, because I reduce, if you reduce before you multiply, your numbers are smaller, which makes the reduction easier, right? If you wait till after the numbers are bigger, you might not see one of them, and then you don't reduce all the way down, and then you get points marked off, right? So I reduce, especially if I know what I'm going to do is, I'm going to find the probability of this, and then multiply it by the probability. They don't have to have common denominators. I can reduce them both right away. So this is 1/13. What's the chances of pulling a 10? 4 out of 52, which reduces to a 1/13. And when you multiply those two together, you get, when you reduce it, you got 4 out of 52 turned to 1/13. Multiply those, and you got that 1 over 169. Make sense? Okay, let's keep going. We're going to go a little quicker through these. We should be getting this. This one is wrong. Don't copy down their stuff. We're going to have to fix it ourselves. What's the chance of pulling an ace first?
4 to 52.
4 to 52. How do we find OR? We have to do probability of, A, probability of, and then minus probability of.
A and B.
And we already figured out A and B, and it doesn't change. It's not like there was a chance of pulling an ace, and then an ace, and we had, you know what I'm talking about, like in our last problem that we just did? There's no chance of that, so can we use this for our and? Did we just find out the probability of pulling an ace and a 10? Yes. Can we use that for our OR down here? Yes. So here's what happens. What's the probability of pulling an ace? 4 out of. What's the chance of pulling a 10?
4 to 52.
So we said we find the probability of that, 4 out of 52, add it to 4 out of 52, correct? And then we would subtract the 1 over 169. Do you see where they made their mistake? This should be 4 out of 52. Why doesn't this even make sense? Whoever edited this book should have just used common logic. How many, let's say, remember, you have a chance of pulling an ace or a 10, right? Your first card has to be a what? An ace. Or your second card could be a 10. Let's make it easier. Let's make it even easier. What if I said, what are the chances of pulling an ace or a 10 first? What are still the chances of that happening? 4 to 52. What if I said, what are the chances of you pulling an ace or a 10 first or second? I don't care which one. It's going to be 8 out of 52 plus 8 out of 52. Are you with me? Even when you do that, which is much easier than this, do you understand that this says you have to pull the ace first? If I pull a 10, is that good?
Yes.
Listen to the question. You have to pull an ace first. That's going to be on the recording. It's going to drive you nuts. You have to pull an ace first. If I pull a 10 first, does that make this true? No. Do you see how I've changed the scenario? I'm telling you, you can pull an ace or a 10 first. You can pull an ace or a 10 second. I made it easier to work. Yes? What are my chances of that happening? 16 out of 52. I still don't have a good shot at making that happen, correct? I'm still less than 50% of that happening. But is their scenario way over, it's over 50% that they're saying that this is going to happen? Common logic, would that even be possible? Did you see how the person who made this book should have looked at it and gone, that percent is way too high. I don't have a good chance of this happening. It should be 4 out of 52 plus 4 out of 52 minus 1 over 169, which I would reduce that. This comes into a good talk with reducing. If I have this, which is 4 out of 52, plus 4 out of 52, and then minus the 169, or 1 over 169. Yes? Can I make 52s become a 169? Their greatest common number is going to be really big. So what I can do is I can reduce these guys individually down to 1/13. Why? I thought ahead, because 13 can become 169 by timesing it by 13. So then I times this by 13. You guys follow me with what I did? So then you would get 13 over 169 plus 13 over 169 minus 1 over 169. And when I do that, that gives me 25 out of 169. Does that sound more realistic? Yes. You guys follow me? Alright, what's the probability of pulling 2 diamonds? What are the chances of pulling a diamond from my first one? Diamond. How many diamonds are there? 13. Don't just start going with 4, because we've been doing 4. This is what I'm telling you. Think. How many diamonds are there? 4, or there's 13. How many out of how many cards? 2. How many for my next one? Remember, it was replacement. It's still with replacement. We haven't changed the question. It's still the same. So you got 13 out of 52, and then what do I do next? 13 out of 52, but what do I do with those two because it's an and? Do I add them? Do I multiply them? Which one? Because it makes a difference. You multiply them. And this turns into 1 out of 4, reduces down to 1 out of 4. Multiply those together to get 116. How are we doing? Nick, how are we doing, bud? So convincing. We doing all right? All right. Any pair. This one's tricky. Let me ask you a question. If I say you have to pull any pair, does it matter what your first card is? No. So I know that some of you are pretty good at feeling things that you shouldn't be able to fail. Okay? But if I give you a deck of cards, you should not be able to fail at pulling a card. I mean, if you try to reach over and like, oh gosh, I missed it. I feel really bad for you. What are your chances of pulling a card for your first thing? Because it doesn't matter what card you pull. Could you pull a card? Could you pull a 2 first? Sure. Doesn't matter what you pull second now. Yes, what are you trying to pull next? You're trying to pull a 2. But when you pull the first card, it doesn't matter what you pull. Could you pull a king and still match a pair? Could you pull an ace and still match a pair? So, what are your chances for the first one of pulling something you need? 52 out of 52. What are your chances of matching that the next time, though? 4 out of 52, because it's replacement. So you put that card back in. Notice Yes. Exactly. Now, what if I got specific and I said pulling a pair of kings? Now it's going to be, instead of this 52 out of 52, it's going to be 4 out of 50. Kind of like we already did with the aces, right? Didn't they do that with aces? Oh no, it was ace and 10. Yes, makes sense? Now, calculate the following with 3 cards, and again, we're still with replacement. We're still with replacement. So 3 of a kind. Doesn't matter what I pull for my first card. Because they haven't said any specific card, right? So I got a 52 out of 52 chance of pulling a card. You're not going to fail. Again, I feel like some of you would pull the instruction card out or something. Something would go, you get the box. I don't know.
You get the box.
So, 3 of a kind. 52 out of 52. Times, what's the chance of matching that up again? 4 out of 52. Times, another matching that up again. 4 out of 52. When you simplify those, you get the 113. Multiply those together, you get 1 out of 169. Does that make sense? Alright, so here we go. Now they said we're going to pull 3 kings. Notice the probability, because they gave us the answer already. Look at how much when we got specific in the beginning, because now, what are my chances of pulling a king first? 4 out of 52, which reduces to 113. What are my chances of pulling a king the second time? 4 out of 52, again reduces to 1/3. What are the chances of it pulling the third time? 4 out of 52, which reduces to 1/3, or 1/13. Now you're taking 1/13 and multiplying it by itself 3 times. Instead of up here, you only have to do it twice, because it didn't matter what you pulled for the first one. You're just going to try to match it up after. Does this make sense? Alright, now we're going to do the same type of problems, but now we're going to do it without replacement. Okay, so now we're keeping our card that we select. What are the chances of pulling an ace first? 4 out of, which reduces to a 113. What are the chances of then pulling a 10 second? Remember, when you do this, you assume, okay, I pulled a card. What did you actually pull? You pulled an ace. You keep that card. Now what are your chances of pulling a 10? 4 out of 51. Does that make sense? Yes? There's the answers. What are the chances of pulling an ace first or a 10 second? This one's going to take a little bit more. So let's, the or, remember, or should kind of like, your ears should perk up a little bit going, uh-oh. Got to do a little bit more work. What's the probability of pulling an ace first? 4 out of 52. Yes? What are the chances of pulling a 10 second? 4 out of 51. And what are we doing with those two? We're adding them, yes? But then I have to subtract the and. You see how they did this? Isn't that what we talked about? 4 out of 52 plus 4 out of 51, and then this number right here, which is this. That's the same one we had right there. You can use it from our answer above, yes? What do they have to do before they can add or subtract common denominators? I'm not going to go over how to make a common denominator. That's a waste of time. Does everybody understand the probability? Okay, 2 diamonds. Okay, what are the chances of pulling a diamond for the first one? Diamonds. You guys are thinking. 13 out of 52. Pulling a diamond for the second time. 12 out of 51. Right? Not what they did. They reduced this. By the way, how do you know 3 can go into the number? If you add the 2 numbers together and 3 goes into it, what's 2 plus 1? What's 5 plus 1? Can 3 go into 3? Can 3 go into 6? 3 can go into 51. 3 can go into 12. And that's how they reduced it down to this 4/17. Remember, it's much easier to reduce when the numbers are smaller than to multiply 13 times the 12 and 52 times the 51 and then try to reduce those big numbers. That'll take you forever. Reduce here and here. Remember, not only can you reduce with this one and this one, but you could reduce with the 12 and the 52. The rule is one has to be in the top, one has to be in the bottom. You guys understand what I'm talking about? Yes, Chris. And now he goes into it. All right, any pair. Any pair. What's the chance of me pulling a card the first time? What's the chance of me pulling it the second time now?
Without
That same card. No, the same like type of card. So a pair. So if I pull a 2, then I need to pull a 2 the second time. No. I assume that I pull a 2 out. So now how many 2s are left in the deck? 3 out of now 51. You with me? Questions? Alright. We're going to finish. I'm going to finish the rest of this. I'm going to do problems 4. And then we're going to do problem 2. You're going to need to finish this up for homework. So you need to go to the video about 31 minutes. You should go in. I'm going to finish this while you guys leave. That's your homework for the night. Eventually, I will be collecting your books and looking through and making sure you've taken notes. If you haven't taken notes, they're up on YouTube. You can always go back and fill in the notes now. Does that make sense? I'll be taking those booklets very soon and entering some grades. Have a good night. Alright, so problem 4, we're going to calculate the following probabilities of drawing 3 cards one at a time, and again without replacement. So probability of pulling 3 of a kind. The first one again is not going to matter, so you're going to have a 52 out of 52 chance of pulling a card. Pulling that next card, remember you're going to keep that card, so now instead of having 4 out of 51, 52, you're going to have 3 out of 51. And the next one is going to be a 2, because you've kept the card here, so you got that card again. Now you only have 2 left in the deck, and there's only 51 cards in the deck. And then when you reduce these down, this can become 1/17. This becomes 1/25. Multiply tops, you get 1 over 425. 3 kings, the probability of that happening is not very good. This is without replacement. So what happens is you have a 4 out of 52 chance of pulling it the first time. You have a 3 out of 51 chance of pulling it the second time, because now you've got the king, so now you only have 3 kings left in there, but there's only 51 cards. Now there's only 2 chances of getting a king, but there's only 51 cards. It reduces down to here, multiply the bottoms, and you get that 5,525. Alright, what kind of events generally correspond to situations with replacement? Situations with replacement generally involve independent events. In this type of situation, the first event does not affect the second one. Situations without replacements generally involve dependent events. And notice they're saying generally. That's not an always or anything like that, so be careful. Alright, so a homeowners association has 25 members. The association needs to establish a 3-member committee. So we want to calculate the probability that Bill, George, and Rio are randomly selected to serve on the committee. So once we pick a person, we're not going to put them back in the pool because they need to be part of that. So then notice in this question, they do not tell you that it's without replacement. You have to understand that because these people are part of a committee, and once you select a person, you're not going to put them back in the pool again. So they're going to be a 3-member committee, so there's going to be 1, 2, 3 selections that are made, and since it's an and, we know that we're going to multiply the probabilities together. So what's the probability that, and it doesn't matter if you pick Bill, George, or Rio first, it doesn't really matter the order, but let's go with Bill first. Chances of Bill being selected are 1. Yeah, that's what I don't like. I don't like this. This is not the probability of Bill. This is not the probability of Bill and George. This is not the probability of Rio. What they should have done, in my eyes right here, is they should have done, this is the probability of, you can get any three of these guys. You can get Bill, George, or Rio picked first. So there's 3 people that can be picked out of the 50, the 25. This second one is now there's only 2 of them left in the pool, so you have 2 out of the 24. Now there's only 24 people left, and then there's only 1 of them left, so you have 1 chance out of the 23. So that's how I would have worded this a little different. I would have made this maybe Bill, George, and Rio, and then I would assume that Bill got picked, so then this would be George and Rio, and then over here just Rio. Something like that. This, hopefully, if you have a question on that, make sure you sequence one. But that should be the reason. I don't like that. That is not the probability of Bill being picked. The probability of Bill being picked is 1 out of 25. But since it doesn't matter if Bill, George, or Rio is picked first, there's 3 chances that one of these guys is picked out of the 25. We assume one of them is picked, then there's only 2 of them left, so then there's 2 out of 24. We assume he's picked again, so there's only 1 left. So we have a 1 out of 2,300 chance that that's going to happen. Now, calculate the probability that Bill is randomly selected as president, George is picked as vice president, and Rio is picked as treasurer. And what they're going to assume, the chance, and they're not giving you a lot of information. We're going to assume that when you pick, the first person that gets picked is going to be the president. The second person who is picked is going to be vice president, and the third person who's picked is going to be treasurer. So the chances that Bill get picked first is 1 out of 25, because Bill has to go in the first one. So we assume Bill is picked. He's out of the running for vice. Second person, there's George. He's only 1 person out of the only 24 that are left over. And then finally we've got Rio. George got picked, so now we got Rio is the only one left in the group, and it's the 1 and out 23. Because up here, remember, it didn't matter if Bill, George, or Rio was picked first. So that's why they had 3 chances out of the 25. And then 2, here, Bill has to be picked first, so there's only 1 out of 25 chances that happens. Calculate the probability of 5 particular being chosen to serve on the 5-member team. So hopefully you're getting this understanding. It's going to be 5 out of 25 times 4 out of 24, 3 out of 23, 2 out of 22, and 1 out of 21. All of them reduced down. Multiply it out. This 3 and this 21 could be canceled out. In fact, that's what I would personally do. I would slash this, make this a 1, slash this, and make this a 7, instead of multiplying it and then having to reduce later on, because you're not going to probably realize that 3 goes into that big old number. So remember, all you're doing is looking for anything on top that can reduce with anything on the bottom, because all these are multiplication, and the 3 and the 21 can cancel out and make that a 1 and a 7, and then you would just jump to write this answer. Alright, calculate the probability of a particular member of the homeowners association being chosen to serve as one of 5 officers. So calculate the probability of a particular member being chosen to serve as one of the 5 officers. Okay, basically what this problem is saying is they are saying they want you to calculate the probability that a member of the homeowner, so one person, is chosen to be, and there's 5 officers. So there's president, there's vice president, there's secretary, there's historian, and then there's the, I don't know, person who starts the meetings. I don't know, whatever. So there's 5 different places that they could be fit. So how many people are there that can, we want one particular member. So what are my chances of becoming one of those 5 things? And so what you do is you're going, well, there's 1 of me, and I have 1 chance out of 25 of becoming president. Okay? Well, let's pretend that that doesn't happen. They pick somebody else. So now I've got 1 out of 24 chance of becoming vice president. Okay, that doesn't happen. So I've got 1 chance out of 23. And when we do that, you have to add them all together. Take all those probabilities and add them all together. So I have 1 chance out of 23, 1 chance out of 22, 1 chance out of 21. This is nasty. You had to realize that this is the greatest common or the least common denominator, which is 1,062,600. That's fun. Then you had to add them all together, and then finally at the end reduce. This is a huge fraction. So that's a tough problem. Should be finishing up here really soon. The menu at a local restaurant offers the following items. So we got this, 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 and this. A dinner consists of one selection from each category. How many different dinners exist? Okay, so again, this is where you're using your counting principle. So how many different options do we have for this one? 1, 2, 3, 4, 5. Then we have 1, 2, 3, 4. So we got 5 times 4. And then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 10. And then 7 different desserts. So that's how they get the total possible. So hopefully this is starting to put everything. What are the probability that this person selects chicken? Well, what are the chances of them selecting chicken? We have 1 out of total of 10 different entrees. So you have 1/10 chance of them doing that. What is the probability that the person selects meatloaf and chocolate cake? So the only thing that's going to be affecting this is they pick meatloaf and chocolate cake. Their salad, their appetizer, has no effect on what we want to happen. So we go and we say the probability of them pulling meatloaf is 1 out of 10. Probability of them pulling a chocolate cake is 1 out of 7. 1 over 10 times 1 over 7 is 1/70th chance that that happens. What is the probability that the person picks steak or another person selects pie? What is the probability that one person selects steak or another person selects pie? So we say, okay, what's the probability of pulling steak? 1 out of 10. What's the probability of them picking a pie? 1 out of 7. Minus, and then remember when we do or, you got to do the probability of steak, probability of pie, and then you have to minus the probability of steak and pie. And so the probability of steak and pie is going to be that 1/10 times the 1/7, which turns into all this. Got to have a common denominator. Add those together. 17 minus 1 is 16 out of 70. Reduce because 2 goes into both of them, and you get 8/35. Alright, what is the probability that a person selects meatloaf? What is the probability that, so here they're doing this and its conjugate, right? Because if they select meatloaf, it's 1 out of 10. Any entree except for meatloaf means it's conjugate, so that'd be 9 out of 10. So those guys are complementary events, not conjugate, sorry. Complementary. Alright, what is the probability? So this column right here is kind of reviewing everything that we've talked about. We've talked about complementary. We've talked about just regular, this is an or statement, we did an and. Alright, what is the probability that a person selects flounder, Caesar salad, and fruit? So what's the probability of them pulling a flounder? 1 out of 10. What's the probability of Caesar salad? 1 out of 4. Probability of fruit? 1 out of 7. Multiply all those together and you get that. What is the probability that a person selects pizza, cookie, and any salad except for a garden salad? So what's the probability of pulling a pizza? 1 out of 10. What's the probability of pulling a cookie? 1 out of 7. What's the probability of anything except for a garden? Well, that would be 3 out of 4 because they're allowed to have a non-garden. So there's 3 things that are not a garden salad. So 3 out of 4. Multiply the tops and top, bottoms and bottoms. All right, what is the probability? So what is the probability that the person selects soup, chicken, any salad, and any dessert? Well, since they are allowed to pick any salad and any dessert, they're not really affecting this problem. So they made them 4 out of 4 and 7 out of 7. To me, I just wouldn't even include them. I would just be like, they don't matter. So what's the chance of them pulling a soup? Would be 1/5. What's the chance of them getting chicken? 1/10. What are those things happening together? You multiply them, you get 1/50th. Hopefully all of this is coming together. That last part should have been fairly easy to understand. And we'll finish up tomorrow. We'll be doing
section or activity 7. Have a good night.